Hey, hello everyone. Welcome back to the free Kubernetes series of day 10, where you are going to learn about the certified Kubernetes admin questions along with answers. And I'll be telling you each and everything with the help of the clear-cut explanation. If you are new to the channel, subscribe to the channel and share the link with your friends. And if you are liking the content, hit a like. Tomorrow's video will be going to be a little bit on hands-on, so you can check that. So let's get started on the CK exam interview questions and answer. And this interview questions and answer can be used or can be asked in your real-time interviews also. So let's get started. So this is task 5. Task 4 we have already completed in the previous videos. You can check that. So in the task 5, the requirement is there is a deployment called presentation, and you have to scale the deployment of presentation to 3 pods. For example, you would have seen that in the Kubernetes, basically there is a pod, okay, P, there is a container, and inside that container, there is an application. So basically you have one pod which is having your application secured. Now, the people are telling that this application pod name is presentation, and you have to scale this presentation pod from 1 to 3. Okay, so 3 pods, you have to scale it. So what are the steps that is required for your application to scale so that it can take the incoming load? Is basically you have to certainly perform some steps. So we will see here. So if you see in the diagram here, as of now, if you are able to do kubectl get deployments, okay, if you are seeing there are 2 types of deployments, one is front end and the presentation. And if you see in the question, the question was asked for the deployment presentation. So what you will do, you are seeing that as of now for the deployment presentation, there is actually a single deployment which is having. And if you see like deployment.apps, again, you are able to see like the containers which are ready in the state. If you are able to see, this is becoming as 3. How this deployment scaling is happening, let's see that. Okay, now if you are able to see kubectl scale deployment presentation hyphen replicas to 3. So here what we are trying to do is we are trying to update the deployments from 2 to 3. So that is the reason, if you are able to see here, the deployment was 2 and here the deployment is 3. And in the deployment, if you are able to see, under the deployment, there are 3 pods which are available. So if you see for the presentation pod 1, 2, and 3, initially for the presentation pod, if you are able to see, it's 2. And when you are using kubectl scale deployment presentation, deployment name and hyphen replicas, it will help you to scale your pods to 3 pods. Very, very simple. The question answer, when someone asks, how do you scale your deployment? You have to just say like kubectl scale deployment name, hyphen replicas, and what type of deployments is actually that one, and the scaled pattern. If you are able to tell this answer, your solution will be something like this. And when you are doing kubectl get pods, you will be able to see the 3 pods of the presentation. Okay, so that is how the answer is to be given. Very simple, very sweet. Now, task number 6. The task number 6 is telling that schedule a pod as follows. The name of the pod is nginx-KUSE00401, and the name of the image is basically this, and there is a node selector disk equal to SSD. So what is this question basically is telling you is that you have a Kubernetes cluster with a master node, and there are 2 worker nodes. Okay, let's say that. And one of the worker node label is equal to disk equal to SSD. So what will happen is when you are adding this label disk equal to SSD, what will happen is whenever the master node scheduler is there, right? Whenever it is scheduling the pods into any of the worker nodes, it has to check only the worker node which is having disk equal to SSD. So that is basically you're selecting the node. You are yourself selecting a node on which node my pod has to get deployed. So here you see node selector disk equal to SSD, and the image name is nginx, and the name of the deployment or name of the pod you can consider like this. Now, if you see on the solution, okay, so let me see API version v1, API kind, metadata spec. These 4 are the important aspects for any of the Kubernetes manifest file. And if you are able to see in the labels, the name is given as nginx KUSE. This is the name of the pod, okay, nginx pod. Now, if you are able to see the specifications, the containers, under the containers, the image name and the port number, basically port number is not given for nginx to run. So basically, if you see image name and the node selector, here there is a under the specifications for the Kubernetes manifest file, API version, kind, metadata, and spec. These 4 are very, very much important. Under the spec, There is a containers name where you are giving the image name, port name, type of protocol, all those things. And finally, you are going to select like node selector on which node, right? My deployment should go. So here you see node selector disk equal to SSD. This is like a key value pair. And this will be making sure that once you are triggering this manifest file, let's say like I have named this manifest file as pod.yaml. So what I will do is kubectl create -f the pod.yaml, and immediately the node which it has to deploy will be this one with the disk equal to SSD label. Okay, very simple. Now task number 7, if you are able to see, right? Schedule a pod as follows. Name of the pod is 𝐘𝐈𝐒8. App of the containers are 2. App container. So basically this task 7 is very interesting task. Let's see. Okay. In the task 7, you are having 2 containers. So basically what it is telling is every pod is having 1 container, bhai. But for this pod, there will be 2 containers running inside the same pod. So how do you do that? Is basically the name of the container. If you are seeing like they are telling to use 2 images. One is Nginx image, one is console image. So how do you do it? Very simple. Very simple. I will tell you the entire structure of this. Okay. So let me tell you. So what this happen is you are seeing, right? API version, kind, metadata, and spec. Under the spec, there will be 2 containers which are going to come. One container which will have the name as Nginx, and the other container will have the name as console. Okay. And all the details of each of the deployments you will be able to see as a different image. Okay. Or the other thing is, sorry, my bad. This is not this. So if you are able to see here, the image, whatever the images are there under the containers. So first, let me change it. Okay. So I'll just take a reference of it, -image 1 and -image and name of the container. Okay. So that's how it is. So under the containers, you need to remember. So these are things like once you practice, it will come. My bad, I missed that. So -name, first image of the container, and -name, the second image of the container. And if you say kubectl create or kubectl create -f app2.yaml, if you are able to see, right? The deployment of 𝐘𝐈𝐒8 0/2. What does you get 0/2? So if you are seeing, right, these labels are having the name of the pod is 𝐘𝐈𝐒8. So when I am doing this 𝐘𝐈𝐒8 kubectl create -f let's say like k8.yaml. So what will happen is immediately you will see that 𝐘𝐈𝐒8 0/2, right? So what does 0/2 means here? If you are seeing container creating state, so it means that the pod has 2 containers and the status of each of the container is still coming up. And finally, once it is coming, you will be able to see 2/2 status. So if I go down, if you are seeing 𝐘𝐈𝐒8 2/2 running status. Okay. So that's how you need to remember. Little bit syntax. If you are doing the issues also, that's fine when you are telling to the interviewer. But when you are doing the hands-on, you have to make sure that you are telling the correct answers to the interviewer. Very important. Okay. So this is how the 2/2 pods, 2/2 containers inside the pod is done in the Kubernetes. Okay. Now let's go to the task number 8. So create a persistent volumes with name app data. Okay. So basically you have a pod. You have to create a pod with persistent volume claim, and you have to attach that persistent volume claim to the pod. Create a persistent volume with name app data. So the persistent volume, basically the persistent volume name is app data. Okay. And a capacity of 2 GB. So this capacity of persistent volume is 2 GB, and access mode is read only. So this particular data is read-only access. The type of the volume is host path and its location is this one. So now what it is telling is, boss, you create a persistent volume. Okay. So you see here API version kind is persistent volume, metadata app data, because the name of the persistent volume is app data. And the specifications capacity is 2 GB. As I have told you, the 2 GB capacity you have to give. And here read write many they have selected, but actually you have to select here access mode as read only. Okay. Now, if you are able to see the host path, which is actually mounted, is basically your SRV/app data as per the details that are shared. Now, once the persistent volume is created, you can see kubectl create -f. Now, kubectl get PV. Once the persistent volume is created, you will say like kubectl get PV. So this will give you the persistent volume as data. Okay. And if you are able to see app data 2 GB, read, write, execute access has been given. But usually when the answer, the question has been a read only. Okay. So now retain available. Now, if you are able to see the difference between persistent volume and persistent volume claim is, you created a 2 GB volume out of the Kubernetes cluster. Okay. So you asked Kubernetes cluster boss, give me 2 GB. Now, as of now, you have 2 GB space with you, 2 GB volume with you. If you want to attach something to the pod, see here, its status is available. And once you attach something to the pod, then it's basically the claim status will be claimed. It means that that particular persistent volume will be claimed by this pod. And the same persistent volume can be claimed by multiple pods. What is claim? Something you are taking from someone, right? So I'm going to claim something, I'm going to take. So the difference between persistent volume and persistent volume claim is you create the persistent volume in the Kubernetes and you attach it to a pod. It means the pod is claiming that persistent volume. Very simple. Okay. So you saw, right? Task number 9, an existing pod needs to be integrated in Kubernetes built-in logging architecture. Example, kubectl logs, adding a streaming sidecar container. Now, very important. What is a sidecar container? You need to know. Sidecar container. Now, what happens, right? Every pod, when it is deployed on the Kubernetes, the main thing which a pod should know is how the monitoring and logging happens. Okay. How the security of the aspect is taken care. Okay. How the behavior of the pod should be once it is deployed into Kubernetes. Now, as I've told you, the pod is just an application, correct? But what if I want to make that application to behave something different? What if I want some supporting applications to be deployed along with the pods? So these are called sidecar containers. So basically what will happen is, inside your pod, you are going to create one more container, and this is called sidecar container. You will have your application inside this pod, and this sidecar container can be used as networking, can be used as maybe you can say like security aspect, can be used for maybe logging aspect, which we are going to do a hands-on. So one pod with the application, this is one pod with the app. Okay, I should not round it. One pod with the application and a sidecar container. So how do you create a sidecar container? This is this task. Okay. So you see here, clearly the Kubernetes manifest file is shown to you. API version, kind, metadata, and spec remains the same. And when it comes to the container, if you are able to see under the specifications, right, there is a container, and in this container, the name of the container is BusyBox. So as in the question, they are asking, right? Okay, let me make it small. Yes. If you are able to see, the name of the container is sidecar here. Okay. And what this question is asked to you, let me explain you in detail. Task. A sidecar container named sidecar using a BusyBox image to the existing pod 𝐵IG app. So this is the existing pod. And in this existing pod, you are going to deploy a sidecar container with name sidecar and using the image BusyBox. The new sidecar has to run the following command. So you are telling that, boss, once you have created the sidecar with name sidecar, your sidecar should do some work for me. Basically, it has to do some logging work for me. So how do you do that? So your logging work, if it has to do, it has to execute some commands. So that commands is this one. So if you are able to see the containers, image BusyBox, name of the container is sidecar, command is bin sh-c tail. So this is basically doing some functionality where it is extracting the logs and it is sending or putting that logs into some file. Okay. Now, if you are able to see, this is one of the image which has been created for a sidecar container. Okay. And if you are able to see little bit down, all the things are with respect to the sidecar container only here. Okay. Very, very much important. So you have your pod and you are going to create your pod with respect to the sidecar container. And if you are able to see kubectl get pods, okay, there is one pod which is telling 𝐵IG app. And for this 𝐵IG app, only this sidecar should work. And how that is working? So you see here, I'll just tell you. Here, some of the annotations are used. What are annotations? Whenever a container is created, if the container is having a dependency on other container, okay, and it has to make sure that this particular pod is attached to some other pod. If you are able to see annotations, kubectl .kubernetes.io last applied configuration. So if you are seeing name of the container or name of the pod with which this sidecar pod has to get applied is basically the 𝐵IG app. So this is what it is helping your sidecar container to get attached. So that is what the reason is. If you are able to see kubectl get pods --KUSC, that was before task we have done, KUCC8, that was before task. And you see only this application 𝐵IG app is having two containers inside it. Rest all, right, are having one. Why this is having two? Because in the previous task, we have added one additional container to this KUCC8 in our deployment. Okay, so that is task 8. Oh, sorry, task 9. Now, if we go ahead a little bit, for the task number 10, what it is telling, from the pod label name, so every pod has a label. Like you go to the supermarket, okay, in the supermarket, every product has a label, correct? So similar way, what Kubernetes is suggesting is, boss, you must have labels for every pod so that I can know like which pod you are going to utilize. So from the pod label, if you are seeing, guys, I'm working very hard for you guys, so just like the video. Okay, sorry. ठीक है, चलो आगे बढ़ते हैं. Name of the pod with a label like overloaded CPU, find pod. So what is telling this? From this label, find the pods running with high CPU workload and write the name of the pod consuming the most CPU from the system to this file. So what is the structure? So kubectl top pods. So as you are aware that the top command in Linux is used to get the CPU average utilization. Along with that, the processes running in the system. So similarly, when you do kubectl top pods, you are able to get all the details of the pods along with the CPU and the memory utilization. So the top command here also help you to get the memory utilization. So every pod, so 𝐵IG app is using 1 MB, right? 1 MB memory. Foo is using 0 MB. This is using 2 MB. So CPU is 00 cores here. Okay. So if you see here, okay, sorry. Yeah. So if you see here, kubectl top pods -L. So here -N, when you do kubectl top pods -L, if I do it overloaded CPU. So what does this -L means? Okay, name equal to -L, name equal to overloaded CPU. So what does this mean is I am filtering out among, like, say, like 100 pods I have, and inside that 100 pods, only the 10 pods are having the label name equal to overloaded CPU. So only the first 10 pods with the name overloaded CPU will be coming to me. And under that also I can sort by equal to CPU. So you see here, maximum CPU utilization is 66, 33, 20 in the order. And what we are trying to do is echo overloaded CPUs, and we are sending it to this one. So if you are able to understand, right, what we are trying to do is whatever the overloaded pods are there, we are sending that data to the text file, and we are catting the text file. So here only one pod is coming, which is having the one deployment name is coming, which is having the 3 pods in it. And the maximum CPU utilizations are utilized by these pods. Okay. So it has asked the overloaded CPUs. Under that, whichever is high running CPU workload, write the name of the pod consuming the most CPU to this file. So whatever the name of the pods are there, it will be writing here. Now, the most the most utilization, the CPU, highest CPU utilization of the pod should be written here. So if you are able to see echo, I'm sending the first value into this text file. So basically this is a shell script itself, echo some text name you are going to send into opt/test.txt file. So that is how the things are happening. Now, if you see task number 11, create a new Nginx ingress resource as follows. So ingress, what is ingress? Ingress is basically the Kubernetes given load balancer. Okay, so it is not an inbuilt component of Kubernetes. Okay, but you have to make sure this is getting created. So what you have to do, it is telling that create a new Nginx ingress resource, and the namespace where you are deploying this ingress resource is this one, and expose the path /hello. So what you are trying to do is this ingress is basically helping you to deploy, to balance your load to send the traffic to the particular pod. So API version, kind ingress, metadata, ping, ing-internal, annotations, as I have told you, specifications, rules. Now, under this, what will happen is which of the paths that I have to send the traffic to. So if you are seeing, there is a, let's say like, first the request is coming to the ingress, and then it is sent to the pod, which is service, which is having the path of /path, okay, /hello, okay. And then it is sending to some pod. And if you are able to see which service of name hello, okay, and the port number is 5678. So that's how the ingress routes the traffic. And under the rules, if you are able to see, I can give multiple rules, guys. Here there is one rule, right? I can add multiple paths under this paths. Paths is plural. So I can have one more path here, which is sending the traffic to path of, let's say, hello. I can say text, and I can have all the prefix, suffix, and port numbers here, and service also. Okay. Right. So that's all for today's video. I think you have understood what is the crux of this video. And if you have liked this video, like, and if you have any questions, comment in the comment section. I'll be definitely helping you with a reply. This document will be made available in the comment section. So please give your valuable feedback, and please take the most of it. All these questions are asked in the interview. You just need to understand which scenario has what type of manifest file to be created. So don't get confused. So thanks a lot for watching, and please watch all the bootcamps on our YouTube channel, and also interview playlists are there. You can watch it. This is Singham here signing off from this video. We will meet in tomorrow's video. Until then, take care. Bye.